Welcome to Pratham Science Academy classes, and we are on exercise 2.2 for question number 1, for which we have to find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So let's get started with question number, the part 1 of question number 1, and our quadratic polynomial is x squared minus 2x minus 8, here a is equal to 1, b, which is the coefficient of x, which is -2, and constant is -8. So let's first get the zeros. So a into c is 1 into -8 is -8. So the factors of -8, for which the product is -8, and their sum is -2, is -4 into 2, which gives us -8, and -4 plus 2 gives me -2. So the factors are -4 and 2, and now I can write this quadratic polynomial as, for -2x I'm going to split this up into -4x plus 2x minus 8. So common is, for these two terms, common is x, which gives me x minus 4, and for these two terms common is 2, so 2 into x minus 4, and now x minus 4 is common, which leaves me with x plus 2. So if I put x minus 4 is equal to 0, that gives me x is equal to 4, and if I put x plus 2 is equal to 0, that gives me x is equal to -2, and I'm going to denote these zeros as alpha and beta. Now let's verify the relationship, which is the sum of zeros should be equal to -b by a, and the sum of the zeros, that is alpha plus beta, is -b by a. Alpha is 4 plus -2 is equal to -b, which is negative of -2 by a is 1. So 4 minus 2 is 2 is equal to 2. The relationship is verified here, and let's verify the product of zeros, which is equal to c by a. Product of zeros is alpha beta, and c is, so this is c by a. Let's put in the values. Alpha is 4, beta is -2, and c is -8 by 1. So this gives me -8 is equal to -8. So the sum of the zeros is equal to c by a. Hence, we can say that the relationship is verified. Okay, now let's move on to the second one. Okay, the second one is polynomial of variable s, so it's 4s squared minus 4s plus 1. Let's write down the coefficient of s squared, which is 4, coefficient of s, which is b -4, and c is equal to 1. So a into c gives me 4 into 1, which is equal to 4. Now 4, I can write it as -2 into -2, which gives me the middle term when if I add them. So I have the factors -2 and -2. So let's split the middle term. So which is equal to 4x squared minus 4s is -2s plus 1. Now the common here is 2s, which gives me 2s minus 1. And for these two terms, I'm going to take a -1 common. So as soon as I take a negative common, so this term is will be positive, and this plus is now negative because I have taken negative common. So 2s minus 1 is common, which leaves me with 2s here and negative 1 here. So s is equal to half and s is equal to half. Both the zeros are equal, so alpha and beta both are half. Now we have to verify the relationship. Okay, so alpha beta gives me half plus half is equal to negative b. B was negative 4 and A is 4. So half plus half is 1 and this is negative, negative is plus. So 4 by 4 is 1. So 1 is equal to 1. And in this case, alpha, this is half into half is equal to C. So C here is 1 and A is 4. So 1 by 4 is equal to 1 by 4. And hence the relationship is verified in this case as well. Okay, moving on to question number 3. Let's move on to question number part 3. Okay, so we are on part 3. So this is the third part, which is cx squared, 6x squared minus 3 minus 7x. Now, in this case, it's not in the standard form. Standard form of the quadratic polynomial is ax squared plus bx plus c. So we are going to write it as, so this can be written as 6x squared and then minus 7x negative 3. So a is 6, b is negative 7, and c is equal to negative 3. And a into c is 6 into negative 3 is equal to negative 18. Now let's get the factors of negative 18, which are negative 9 and 2, because negative 9 into 2 will give me negative 18, and negative 9 plus 2 will give me negative 7. So I'm going to split up the middle term. So instead of minus 7x, let me write minus 9x plus 2x minus 3. Common is 3x for these two terms, which leaves me with 2x minus 3, and for these two terms common is 1, so this is 2x minus 3. So 2x minus 3 is common, and this is 3x plus 1, which gives me x is equal to 3 by 2. If I assign this to 0, and this gives me x is equal to negative 1 by 3. So these are the two zeros, and let me write it as alpha and beta. So alpha is 3 by 2, it's minus 1 by 3. And now let's verify the relationship. Okay, the first it's 3 by 2 minus 1 by 3 and negative b. B is negative 7 and a is 6. So if I take LCM here 6, this is 9 minus 2, which is equal to 7 by 6. And 7 by 6 is equal to 7 by 6. Relationship is verified. The product of the zeros, and the zeros are 3 by 2 into negative 1 by 3 is equal to c. So c is negative 3 and a is 6. So this leaves me with minus 1 by 2, and this is also minus 1 by 2, and hence the relationship is verified in this case as well. Okay, now let's move on to question number 4. Okay, for question number okay, we are on question number 4, and the polynomial is 4u squared plus 8u. And in this case, A is 4, B is 8, and C is 0. So we can take 4u common in this case. So let's try to factorize this. 4u is common, which leaves me with u plus 2. And if I put 4u is equal to 0 and u plus 2 is equal to 0, this gives me u plus u is equal to 0 and u is equal to negative 2. So alpha is 0 and beta is negative 2. And let's verify the relationship. So the sum of the zeros. So the 0 is alpha is 0 and beta is negative 2. So that is negative, and B is 8 and A is 4. So negative 2 is equal to negative 2. Now let's verify the product of the zeros. So it's 0 into negative 2. C is 0, A is 4, so 0 is equal to 0. Hence, the relationship is also verified in this case. Okay, let's move on to the next one. Okay, the next one is quadratic polynomial is e square minus 15, and I can write it as a square, and let me write 15 as root 15 square. So this is a square minus b square, and a square minus b square is a minus b into a plus b, which gives me t is equal to root 15 or t is equal to negative root 15. So I have got two zeros. So let one be alpha and other be beta. And let's verify the relationship. Okay, so this is root 15 plus negative root 15 is equal to minus b. So in this case, a is equal to 1, b is equal to 0, and c is equal to negative 15. So b is 0, so this is 0 by a, which is 1, which is 0. So this gets cancelled, 0 is equal to 0. Relationship is verified here. And in this case, so it's root 15 into negative root 15 is equal to c. So c is negative 15 and a is 1. So this is negative 15 is equal to negative 15. Hence the relationship is verified. Okay, for question number 6. Question number 6 has the polynomial 3x squared minus x minus 4. And a is 3, b is equal to negative 1, c is equal to negative 4. So a into c is equal to 3 into negative 4 is equal to negative 12. Now negative 12 has the factors minus 4 and 3, because minus 4 into 3 will give me the product minus 12, and minus 4 plus 3 will give me the middle terms coefficient, which is negative 1. So this is vx squared minus 4x plus 3x minus 4, and here the common is x, so this is 3x minus 2 plus 1 into 3x minus 4. So this is 3x minus 4 into x plus 1. So this gives me x is equal to 4 by 3 and x is equal to negative 1. And our zeros are alpha and beta. Okay, now let's verify the relationship. Put in the respective values of alpha and beta. So this is 4 by 3, negative 1, and this is negative b. B is negative 1 by A is 3. So if I take LCM here, this is 4 minus 3 and this is 1 by 3. So 1 by 3 is equal to 1 by 3. And the next one is this is 4 by 3 into negative 1. C is negative 4 by 3. Okay, so this is negative 4 by 3 is equal to negative 4 by 3. And hence the relationship is also verified in this case. So we are done with all the parts in this also question number 1. Do like, share, and subscribe. Thank you for watching.